I mean, this is going to be a bit of improv theatre because otherwise it's almost like a deja vu situation, because we did talk about using the models. I think I'd start by setting up. We'd have a game. We'd have a play with a few toys. I mean, you can't go wrong with that. Clearly, I just did. What's the record in terms of conductivity on the number of people?
I had 60 people attached to a duck.
Attached to a duck?
Yes. Well, one of the bath ducks, the obvious duck.
Oh, right, one of those, yeah.
Yeah.
About 30.
It's the same thing.
It's the same thing. Yeah, about 35 kids, but I've not gone any further, so I don't know. About 6. And it's playing with the models and things like that. And we then go on. We say we talk about how it would work, and that's how we'd introduce the models. What models would we use with the children, with the students, to try and explain it? And we think that they're likely to come up with pizza delivery or Tesco's delivery or that type of thing. And then, although our breakdown sheet wasn't quite as exquisite as John's, as I say over here, although mine in the future will be, because I'll be using that. We came with the same issues, and asked to critique and pros and cons of the models that we use. The idea being, hopefully, directing them towards the road model. Although we thought we should also start being critical of the road model, because one of the things we need to do is get them to critically analyse all the models they use, not just say, ta-da, this is the best one ever to use, this has got no issues at all. Clearly there are, like any model, there have to be issues with the road model. We just feel that the road model probably breaks down a lot further ahead than some of the others, so you can get through a lot more. And one of the things was we're not quite sure it works so well with potential difference as perhaps current or resistance.
Can I just say we agreed with that,
Yeah.
and what we were looking at the tension in the road as being
Yes,
a potential
exactly.
difference,
Yes.
and that's more difficult to observe in the road model than somebody pulling it or somebody's handling it.
Absolutely.
It shows it by the tension.
Shows it, but it's harder
It's
to
difficult
visualise
to-
it. It's harder to make it harder to show exactly. So there might be an issue in terms of a real circuit. How do you get the electrons to move? Which is where we moved into the real circuits, and to keep the fruit going, you can't go wrong with one of them. They all do it. They all do fruit cells. All teachers do fruit cells, but they quite often do it as a project at the end of the sequence of work. And you go, look, isn't this fun? A fruit basket, and then walk off. But just to actually take it a little bit further and say, okay, so what is it doing? Cool, thank you very much. Always a bit of a show off, so I'll go with big electrodes. Well, I did have one teacher who said, I did this last week, but the technician gave me dead lemons. Show me how you did it, and things like that, and she was just using 2 copper lamps. She was just using the same metals on both sides and things like that. Dead lemons. Obviously they died when they came off the tree. So, I'd set up the competition. How are we going to get the maximum possible... I cringe to use the word voltage, because I keep saying if you're going to use the word voltage, we should be using the word meterage and heightage and ampage and things like that. But it is in general use, isn't it? So, how are we going to get the maximum voltage out of the lemon?
Slice that.
Slice it up.
Yeah. Put the slices between your 2 plates and put the 2 plates.
Oh, a voltaic pile.
Oh.
Isn't it?
Oh, well, if you've then got the 2 plates.
You've got the 2, yeah, well, so you slice it up. Okay, so we could slice it up. You need to make a juice, you roll it, get as much juice out of it as possible. Or, I mean, we can do the same thing, of course, with just holding it in your hands. You don't even need the lemon, you can just hold the 2 metals in your hands. Because then you can generate a voltage, you generate a potential difference just the same way.
This isn't one of those love tests, is
It is more or less one of those little tests.
How much do you love physics?
Oh, hang on, it's just gone to 0.
Bear with me a minute. 6.2, no,
6,
0.62.
And one of the things, of course, is that, and I wouldn't say this to the teachers necessarily, but the fact is that actually they are all physicists, because chemistry is a specialised branch of physics, and biology is a specialised branch of chemistry, so therefore they are all actually physicists, they just don't know it, basically. So I'd say to the chemist in this department, okay, so why do we need two different metals? And they come up with electronegativity and things like that, and say, okay, so if you were to hold those in your hand, you've got an aluminium plate and a copper plate, which one's the most electronegative? Copper. I think copper's 1.9, aluminium's 1.6 or something like that, so aluminium's more likely to give up its electrons than copper is. That's why it's more reactive. So if you're going to do electronegativities, we would do that. And I think I'm going to take your those on your B's in future, and just hold them and then do that. And as soon as I do that, beads will start flying. And that's the point. That is I think. And I think it's the difference, isn't it? It's the idea. It's back to the difference between the two sides and the negatives and positives and things like that. It's that point, and they know that. I mean, a lot of the science teachers I've worked with actually know it, but they don't know that they know it because they're happy with electronegativity, happy with the chemistry, things like that. But because it's physics. And that's taken, we say, well, what can we power with? What can we power? Once we've set that difference up, what can we do? And we then go into the big sort of, let's find the most negatives we can. Let's put magnesium on one end and some copper on the other. Let's put magnesium and platinum. Don't get much platinum. Get the differences. Set up a big challenge. That's a nice little toy. Freely available. It's a soil clock. Same principle. The clock is just running off two different metals stuck in the soil, so take that around with me as well and let them play with that. And it's things like that, it's a big win. So as I say, it's not a huge acting because everybody pinched all our ideas in